Example 2, differentiating a function with arbitrary constants. So we're going to differentiate the function f of t, which is equal to square root of t times a plus bt. So we're going to do this in two forms. Okay, the first one we're going to try is using the product rule. Okay, so we're going to call this A. So we're going to use this using the product rule. Okay, so we want to find f prime of t. So if we want to find f prime of t, using the prime notation, we're going to let f equal the square root of t, and we're going to let g equal a plus b times t, where a and b are constants. Okay, so recall that the definition of the product rule using prime notation is taking f, multiplying it by g prime, plus g times f prime. Okay, so we know that f represents the square root of t, and we're going to multiply that by the derivative with respect to t of g, which is a plus b t. Plus, we're going to take the function g, which is a plus b t, and then we're going to multiply that by the derivative with respect to t of the square root of t. So now what we're going to do in step 5 is that we have the square root of t times the derivative with respect to t. So we know that the value of a is a constant. So when you take the derivative of that, it's going to give us 0. And then when you take the derivative of bt, then what's left is b. Plus, we have a plus b t. And now we need to find the derivative of the square root of t. So recall that the square root of t is the same thing as t to the 1/2. Okay? And when you find the derivative, that means you're going to take 1/2 times t to the 1/2 minus 1, which then gives you 1/2 times t. Since that's minus 1, that's minus 2 over 2, which is negative 1/2. So recall, that is what the derivative is of the square root of t. So therefore, this is going to be times 1/2 t to the negative 1/2. Okay, so let's go ahead and rewrite this a little bit better here. Okay, so we have the square root of t, or we can say that this is b times the square root of t plus, okay, now we want to write this so that we don't have any negative exponents. Okay, so if we do this in steps here, we know that this is a plus bt times, well, this is the same thing as 1 over 2 times the square root of t, because that t to the negative 1/2 has to become in the denominator. So therefore, now we can rewrite this as a fraction. So we're going to have b times the square root of t plus a plus bt in the numerator divided by 2 times the square root of t. Okay, so now what we want to do is we're going to combine these two by finding the common denominator. So if the denominator here is 1, then we need to simplify. Well, we can see that the common denominator between 1 and 2 times the square root of t is 2 times the square root of t. So what does that mean? That means we need to multiply the numerator and the denominator by 2 times the square root of t. So we end up getting 2 times b, and the square root of t times the square root of t is t, plus a plus bt. So if we combine like terms, then we end up getting a plus 3bt divided by 2 times the square root of t. So now let's take a look another way that we can solve this problem. Okay, so what we can do first is if we look at the function f of t, and we have the square root of t, and we're going to distribute it to both of those two terms, then what we end up getting is a times the square root of t plus bt times the square root of t. Okay, so this is what we do at the beginning, all right? So if we do that first, okay, and then if we first use the law of exponents to rewrite f of t, then we can proceed directly without using the product rule. So what I mean by that is that before we go any further, f of t is now going to equal a times t to the 1/2 plus b times t to the 1/2. Okay, and then keep in mind here that if we want to simplify that second term a little further, okay, when you multiply with the same exponents, that means you can add, when you multiply with the same base, you can add your exponents. So that becomes what? 2 over 2 plus 1 over 2. So we know we get t to the 3 over 2. So this is b times t to the 3 over 2. Okay, so now what we can do is now find the derivative of this function. Okay, so we know that n represents 1/2, so we're going to have 1/2 a times t to the 1/2 minus 1. Well, that's 2 over 2. Plus, we take n, which is 3 over 2, and then multiply that by b, and then t, which is 3 over 2 minus 2 over 2. And so then we get the derivative to be 1/2 times a t to the negative 1/2 plus 3 over 2 times b times t to the 1/2. Okay, which is equivalent to solution number 1, but let's just see what that looks like if we actually simplify this further, so we can make it look like the solution to part 8 here. Okay, so if we want to combine like terms, all right, so we have we have a in the numerator, and then in the denominator we have 2 times the square root of t, plus in the numerator we have 3b times the square root of t over 2. So now if we wanted to combine like terms, we need to find a common denominator, which we know the common denominator is going to be 2 times the square root of t, and this is also 2 times the square root of t. So that means that the first fraction, we just need to multiply this by 1. And then over here, we're going to multiply by the square root of t, and then times the square root of t. So we get a over 2 times the square root of t, And then over here we have 3b square root of t times square root of t is t. And so therefore we end up getting a plus 3bt over 2 times the square root of t. So if you noticed here, in the second part, we didn't have to use the product rule. Sometimes it's a lot easier that if you have these terms and you can just, multiply, you can then go back to the original part. But then sometimes you may have to use the product rule if you have one term and another term that contains a variable. In this case, the a was a constant, which allowed us to be able to then distribute both of those. So, if we summarize what we have above, we can say that example 2 shows that it's sometimes easier to simplify a product of functions before differentiating than to those using the product rule. So in example 1, however, the product rule is the only possible method that we saw from the previous example.